Hello, good morning, good afternoon, and good evening, wherever you may be. Welcome to the AWS webinar called A Walk Through the AWS Cloud, Application Hosting on AWS. I'm your host, Markku Lepisto, Technology Evangelist for APAC region at Amazon Web Services, and I'm working out of Singapore. So today, let's look at these agenda items. First, I'm going to tell you some best practices how you could focus on your business, how you can automate and scale your application. Then we look at some design best practices for the cloud. And finally, how you could use data to drive your business and iterate your application to become better suited for your customers. So let's start with the focus part. Basically, it all comes down to this. You should really focus on your business. And you should try to outsource what we call undifferentiated heavy lifting, because you don't want to be this guy anymore. You basically just want to make an application or service, you want to provide it for your customers, but you don't want to waste your precious, scarce resources on undifferentiated heavy lifting like managing and building infrastructure, owning and operating data centers or databases, etc. So the best practice here is that you should really simplify what you do. Outsource the systems that are undifferentiated as services that you just rent. In the legacy way of doing IT, basically with building, managing, hosting your own on-premise infrastructures, you actually spent a lot of your time and energy on managing that infrastructure. And basically not enough time was left for your differentiated action, which is improving your service, basically coding your business logic. So now, with AWS and cloud-based infrastructure, platforms, and services, you can just focus your energy and your effort on your business logic improvement, your application coding. And then a certain amount of, reasonable amount of energy on configuring your cloud assets. So let's start by looking at how you should automate and scale your service. We start with the most simple building block, Amazon EC2 or our Elastic Compute Cloud. That's the main core utility that you need to start with. Basically, that is your virtual machine or cloud instance. And how do you get your cloud instance? Well, on the bottom left, you can see the AMI or Amazon Machine Image. We have a lot of public AMIs that you can start with. So the idea is that you choose the most relevant public AMI, like Linux or Windows instance image, then you boot up an instance, and maybe you customize it to your liking with your application code, your binaries, whatever you need to build your service. Then you can rebundle this instance into a new custom AMI. But there are a couple of best practices how you could do it. And this really depends on your own personal preferences. I'll show you the major ways how people do this. The one on the left is called the fully pre-baked AMI. In this version, companies like Netflix prefer to have a fully pre-baked AMI which say just boot up, spin up an instance and start. There is no configuration, no orchestration happening anymore. All the binaries, configurations, etc. are built into the AMI. And by the way, if you're interested, Netflix has open sourced their Netflix OSS suite, and one of the tools is called the Aminator. So that's one way you can pre-bake your AMIs if you're interested. The other way, what some companies and people prefer to do, is to use a so-called just enough operating system AMI. So really minimal set of operating system binaries that are just providing the basic core services from the operating system that you need. And on top of that, they use tools like Chef, Puppet, or Ansible to finish loading the binaries, setting the configurations, and starting the application services. So this really depends on your personal preferences. Now, why did Netflix choose the one on the left? The reason is that Netflix wanted to avoid a couple of things. They wanted to avoid the slowness of orchestrating. They may spin up hundreds of virtual machine instances at a time, so they wanted them to come up as fast as possible. The second reason is that they wanted to avoid any potential failure mode related to the orchestration engines or management systems, or the repositories from which they download their packages. But again, cloud is flexible, it gives you choice, so you can play with these different options and choose the one that works best for you. However, I recommend a couple of things. Do not anymore use bash scripts. Use smarter configuration management tools like Chef, Puppet, or Ansible, and make sure one thing. When you boot up your instance, you do not have to SSH in. If you need to SSH into your instance to finish any configuration tasks, you're doing it wrong. You need to be able to fully automate spinning up your instances and that they start all the services necessary for your application and nothing else. Make sure that you're not running anything that is not needed for your application. That is just waste that you need to manage, and it could be a security hole as well. So lock down and remove all the services you don't need. And remember, you can use the AWS Trusted Advisor to do a security audit of your system as well. So now you have your AMI, whichever way you want to build it, and from this you can spin up your customized application instance. The next thing that I recommend is optimizing the instance size. It really depends on your application stack, your middleware, and your product program. How many resources do you need? So please look at the AWS CloudWatch metrics for CPU, I/O, memory, etc., and optimize the instance size, performance, and resources compared to your application. You need to do a performance test to make sure that you don't run out of resources in a given instance type. If you do, try booting up a larger instance type and executing the performance test again. But don't run too high instance types, because then you just have waste. And at AWS we have currently 17 different instance types available, from really small micro instances all the way up to cluster compute and GPU instances with SSD disks, etc. And remember, it's a balance between resources available and cost. Now, CloudWatch helps you investigate your current resource utilization of your instances. But it's also used for another task, autoscaling. So by changing the instance type, basically rebooting your instance with either a larger or smaller instance, you're scaling vertically or up and down. However, the best practice in the cloud is to do horizontal scaling, what people call scaling out or in. And the easy way to achieve this in AWS is by creating an autoscaling group with an associated launch configuration. So basically, all you do is that you define what are the AMIs that need to be booted. So for every application tier, you would have a launch configuration which is pointing to your customized AMI, your machine image. And then in the autoscaling group, you set the rules. What are the metrics, like CPU load, memory, or even custom metrics like your application internal buffer sizes, queues, etc. What are the metrics that the system should be looking at to detect when your instances are overloaded or getting loaded? And then, what are the actions that are happening automatically when you reach these thresholds? For example, to scale out the system by adding more instances, or to scale in by removing instances from the group to save costs. Then a reminder, cloud computing is a little bit different. You should not just lift and drop legacy servers into the cloud. In the legacy ways of building IT, in your data center, you have servers which had high identities. You gave them names like Ferrari, Lamborghini, or maybe March and Homer. You would log into them. High identity means that servers would have highly unique and specialized configurations. At scale, this becomes unmanageable, because in the legacy way, every server was highly tuned and optimized and unique. And if your servers got unhealthy, then you got worried for them and you nursed them back to health. That doesn't work in the cloud. That doesn't scale. So the way to think about the cloud virtual machines or instances is that they are cattle. They are all supposed to be identical. If you spin up hundreds of them, you don't have time to give them names, and you don't want to give them high identities or specialized configurations. Cloud instances implement a known good state. And if they deviate from this known good state, or if they get unhealthy, then you shoot them in the head and you replace them with another one. Okay, so until now we have an AMI, we have customized, optimized instances, and we have autoscaling groups. Now, we can use autoscaling with different ways. One of them can be looking at queue systems, but a very handy way of doing autoscaling is to put a load balancer in front. Our Elastic Load Balancing service is a natural brother and friend of the autoscaling groups. And the recommendation here is that you would start load balancing from day one, even if you want to save cost and just work on one development and testing instance. Why? Because when you're actually then taking off, going into production, you don't want to change your architecture in the middle. Basically, it will be the same as changing the engine on your airplane just when you're taking off. So the best practice is to start autoscaling and elastic load balancing from day one, but you can set the group size to 1. Then you even get self-healing. With a group size of 1, if your instance becomes unhealthy, autoscaling will just replace it. But it will keep the number of instances in your group as 1. Later on, you can just increase the limit to meet the production load demands. So now we have an autoscaling group that is automatically scaling out and in the number of instances based on metrics. And in front of that, we have the elastic load balancing, and ultimately we will want to then point our domain name to this system. So how does elastic load balancing work? Well, in the morning there's very little traffic and you can maybe get by with 1 instance, but I recommend 2, minimum 2 of everything. You don't want to have single point of failures. Then at 10 in the morning, your system starts getting hot, there are more people logging in, metrics will show this, and autoscaling will automatically do an action, which is to add an instance. You can configure and specify how many instances to add at a time. Is it 1 or is it more? Then you get a new instance, and autoscaling will notify the load balancing service that, hey, there's a new instance in the group. Load balancing system will execute health checks. And if the new instance passes the health checks, it seems operational, it is added to the active pool. And it will start getting some load, which is then offloading the traffic from the original instances and balancing the load equally. In the evening, at some point, the load will taper off, system will become cool, and it will trigger another threshold, another watermark. We call it the low watermark. The system is so cool that we can actually remove instances to save costs. We scale down. Because you don't want to do this. You really don't want to have a success disaster. The worst thing that can happen is that people really love your service, but so many people are using it that they basically suffocate your system, and then people will vote with their feet. They will just move to another service. So make sure that you don't get this problem with your service. Here's a customer example. Animoto have a really nice service where you can upload your pictures and they make a really cool video with music, everything out of your pictures. Now, what happened to Animoto? They launched their service and then in Facebook they went viral. But because they use elastic load balancing and autoscaling, they were able to meet the demand. You can see here in this graph that in just 3 days they went from about 40 instances running to over 3,000. And by the way, those dips down there, those are not problems, those are not crashes. Those were autoscaling, removing instances when they were not needed. So scaling up and down the system as needed. Here's another example from Pinterest. Pinterest is another popular service. They, first of all, use different types of instant pricing models to optimize the costs. On the bottom there, which is the steady state traffic, they use heavy utilization reserved instances, which give them volume discounts. Then they have light reserved instances and on demand. So first of all, that is cost optimization. The second part is the load balancing part. You can see that at night time they run less instances. The effect is that during the peak time, during the days, their cost is $52 per hour. But at night, with less instances, they only pay $15 per hour, and still they serve all the traffic, and people are happy. They achieve 71% savings by doing this optimization. Then, remember, the recommendation was outsource anything that is not core business to you. Outsource them to services. Database is another great example. Databases are really difficult beasts because you need to have DBAs who really know, they live with the database solution, they know how to install it, configure it, patch it, maintain it, scale it, and shard it, etc. This is a really, really difficult task that requires specialized competence. Maybe you're a small startup, you just want to focus on a business logic code. So outsource the database management to something. At AWS, we have services that let you have fully managed databases. First of all, we have our relational database service, which is a fully managed SQL solution. You can choose between MySQL, Oracle, and Microsoft SQL Server. They are scalable, they are fault tolerant, they can be multi-AZ with the click of a button or command. Basically, you don't need to install or manage databases, you just use them. So use RDS for SQL purposes. But then, there's another type of databases called NoSQL. And here we have the Amazon DynamoDB. The really interesting thing about DynamoDB is that it gives you predictable performance. It gives you sub 10 millisecond response times for reads and writes. So suddenly, with the DynamoDB, if you're able to use a key value store, your bottleneck is no longer the data tier. A lot of the web scale companies have been saying that their data tier scalability is the #1 headache for them. What DynamoDB does is that it gives you a zero maintenance, unlimited scale key value store with predictable, consistent performance. That probably moves the bottleneck then somewhere else in your application, but that's a good problem to have. And the best practice here is to consider using both. Use SQL for those complicated queries that you may have, and use the key value store for really high performance puts and gets for keys and values. Here we have a couple of customer examples. Gumi, a Japanese game developer, is using Amazon RDS to scale. So compared to their previous legacy solution, they were able to scale to far higher number of users and reduce their time to market and development time using Amazon RDS. And Halfbrick, an Australian game developer, is using DynamoDB successfully to scale. They really like the solution, and it allows them to free their time to focus on the application development versus managing the database tier. If you need to scale your RDS solution excuse me, for even higher reads and writes, then you can really easily create read replicas. So read replicas are asynchronously replicated copies of your database in RDS. You have your master database, and then you can create read replicas. And what you do is that on your application side, on your SQL client side, you direct the reads to the read replicas. And this is offloading the master, but so that it can only handle the writes. This is offloading I/O from the master, reads are going to the read replicas. If you need to increase your SQL backend performance even more, the recommendation is to use a caching tier. We have the Amazon Elastic Cache, which is a Memcache compatible in-memory cache. When you use Elastic Cache, you can direct a lot of the calls away from the master database into the Elastic Cache tier, again offloading the master database. Now, let's talk about the application management. Ultimately, you want to automate everything. You want to have efficiencies and you want to scale. You have a lot of different options how you manage your application. On the left is the easy, convenient, outsource as much as you can option. On the right are the options for I want to have full control of everything. So the most extreme option on the right is that you just use the bare EC2 and you manage configurations, application management yourself. You can do that, but again, is that your core business? So in this webinar, I'm going to be recommending two options that I think are relevant. The first one is AWS Elastic Beanstalk. This is a management solution that really lets you focus on just your core business, which is your application development. Here, basically the idea is that you make application versions in your development and testing. You have here versions 0.8, 0.9, 1.0, etc. and you need to test them first. What you want to do is just drop in your application into a platform that can create test environments that are cheap, small, and then production environments that are scaling to meet the demand from the customers. And you just want to focus on the application development. Amazon, AWS, Elastic Beanstalk lets you do this really easily. You just basically drop your application package into Beanstalk. Currently, we support the following containers, different programming languages, and we are all the time adding more based on customer feedback. So please let us know if your favorite languages or execution environments are not listed here. Please let us know either in the feedback or letting us know offline. So how does Beanstalk work? You just focus on the green part. You create the application business logic code, and you can outsource the rest of the stack to Beanstalk. That includes all of the physical, operating system, language execution environment, web servers, application servers, etc. Beanstalk manages those for you. What happens is that Beanstalk will create automatically provision the resources in EC2 and associated services, like load balancing. You don't even need to configure the load balancer yourself. You can set the rules, but you don't need to manage it. So Beanstalk creates the Elastic Load Balancing service. It creates the auto-scaling groups. You can override the settings if you want, but Beanstalk manages them for you. Then Beanstalk deploys the right number of instances. So it's right-sizing your environment based on the load. And it manages everything, including RDS databases, if you want a database for application. And it provides you with a CNAME where you can point your traffic. A CNAME is the domain name for your solution. All the logs and all the application versions are stored in Amazon S3, which is our storage for the internet. And remember, S3 has 11 nines of durability. So how do you get your application into Beanstalk? Well, you can integrate your application development environments like Eclipse directly into Beanstalk. You can just publish to Beanstalk, launch to Beanstalk from Eclipse. You can use Git, so you can use command line to push your application new versions into Beanstalk for development, testing, or even production environments. So this is a really handy way of integrating your development, testing, integration, and production systems into a continuous integration, continuous deployment flow. The next option is what I like to call infrastructure as code, AWS CloudFormation. This is another way, which is a really handy way of managing your environments, your applications, and the associated infrastructure. Ultimately, you want to run something like this. So this would be your total solution. It uses different services. You've outsourced the undifferentiated Markku to AWS. You focus on your application development. You use a lot of services. So this is a total solution. How would you get this deployed in a really efficient way that is repeatable, fast, and cost efficient? CloudFormation lets you do this by basically letting you describe your total solution as code. So CloudFormation templates are JSON-compatible text files. So basically, you describe your entire solution as a text file, and you can store this in version control. And this is giving you amazing opportunities and possibilities. The CloudFormation templates have a structure. Basically, first you have headers, then some parameters. You can do mappings like if I'm in region Singapore, my AMI is this. If I'm in region US East, then my AMI is that. Then you define the resources that you want to utilize, like load balancing, RDS databases, etc. And then outputs, like this is the URL to my application. This is the production system. Here's an example, a snippet from the CloudFormation template. This is an example of creating a distributed, replicated RDS database using CloudFormation templates. This example will create a MySQL version 5.5, which is, by the way, multi-AZ enabled. One of our customers who is successfully using CloudFormations is NASA. So the Curiosity Mars rover, when it's downloading, sending the data from Mars back to Earth, it's received by NASA, and then NASA TV is broadcasting the content from Curiosity to the rest of the world, including transcoding, managing the content. So how do they achieve this? They have a CloudFormation template that describes a stack. This stack has load balancers, it has Nginx servers, etc. And when they needed to scale, they just added more of these stacks. With a one-click rollout, they were able to scale the system to meet the global demand when people were excited and they were watching the Curiosity rover landing. Now, you've built your system, then you need a domain name. What you do is that you register a domain name for yourself. But where do you put this domain name then? Well, we have a service called Amazon Route 53, which is a fully managed, always-on global domain name service. So here in this solution now, we have a relational database service in the backend. We have the auto-scaling group of our application instances. We've got the Elastic load balancer in front, that's health checking, and balancing the load to the alive application instances. Then you have your domain name, mywebsite.com. You can basically associate this domain name with the Amazon Route 53 service to, for example, an Elastic load balancer or a CloudFront distribution, which is coming later. This is a really handy way of managing the global DNS service. And if you want to go global, there's a handy option of doing multi-region latency-based routing. So what happens is that Route 53 will analyze where is the user, where is he coming from, what is the latency from the client to the different regions where you have deployed your service. And Route 53 will send a response and direct the user to their nearest region where you're running your service. Then you can optimize the service delivery time with the lowest latency for your customers. Another way of optimizing the service delivery is by using our CloudFront Content Delivery Network service. This is really important for static, dynamic, and streaming content delivery. Basically, you don't want every single request for the pictures, for the videos, etc., hitting your web servers and loading your databases. Furthermore, you want to serve the content from a location that is near the subscribers, near the users. Here we have groups of users from London, Paris, and New York. And with the CloudFront distribution, we can cache the content near the users. That gives them low latency, high bandwidth connectivity. And furthermore, it's also offloading the backend systems. So when you look at the graphs here, compared to not using a content delivery network, if you use content delivery network like CloudFront for static content, you can reduce the response time, make it faster, and you can also reduce the server load, which means that you can scale down your system and save costs. To improve the system even better, you can use CDN not only for static, but also dynamic content. As an effect, using the cloud, you can go global in minutes. There is nothing preventing you from going global with your service. You can start in your own region, but if you think that your service has global appeal, you can basically just replicate your system using, for example, CloudFormation templates and just deploy it in all of our 9 regions if you want. And then to speed up the content delivery, we have 42 edge locations. The edge locations are hosting our Route 53 DNS service and the CloudFront Content Delivery Network. Now, let's look at design for failure, architecture patterns. This is your simple goal. Your application should be always on. It should continue to function delivering the service even if the underlying system components fail are removed or replaced. So a couple of simple rules. Don't have any single points of failure. Analyze your architecture. You can use the help of our solution architects at AWS. Identify any single points of failure and take mitigating actions. Remove those. Then, failure should not be an exception. Failure of component systems and services should be considered a normal action. So assume that ultimately anything and everything can fail and then design backwards from that. So the first best practice is to use multi-AZ deployment. First, a reminder. Some of the AWS building blocks are inherently fault tolerant. So when you look at the list of services on the left, all of those services have built-in high availability and fault tolerance on region level. And the services on the right are fault tolerant with the right architecture, including using EC2, EBS, etc. So let's take a look. Here we have two availability zones. So availability zones are basically data centers within the same region that have low latency network connectivity between them. They have isolated network connections, power connections, floodplain, etc. So let's start with the database tier. You have your master database. We are using Amazon RDS service here in this example, for example with MySQL. You can just handily with one click, command line or API call, make a multi-AZ replicated RDS solution. Then you have your database master in one of the availability zones, and we will automatically create a standby synchronous replica in another availability zone. In the unlikely event that this master goes away, something happens to it, we will switch over the database, we will promote the replica to a new master. And to make sure that there is always a replica, we will start automatically then creating another synchronous replica in the background, in another availability zone. Your application clients will then fail over the connections from the master, the old master, to the new one in another availability zone. That's not enough. You also need to have multi-AZ deployment for your application tiers. So you can very handily and easily expand your auto-scaling group to span over multiple availability zones. And then the Elastic Load Balancer will distribute the traffic to instances across multiple availability zones. Basically, you will want to be able to withstand the total loss of an availability zone so that none of your application tiers are hosted fully in only one AZ. Don't have all your eggs in one basket. And then, practice failures. There's a concept called game day. I recommend looking into this. Netflix has built a really interesting service that they have open sourced as part of their Netflix OSS suite called Chaos Monkey. Netflix is running this in production. What it does is that it will disable instances in production. So failure should be a commonplace incident. You should be able to withstand individual component failures without the whole service suffering so that the KPIs don't go down for the end user. So take a look at Chaos Monkey and even consider running it in your own testing environments. Basically, with the Chaos Monkey, you can introduce failures into your system and make sure that you can survive them. Next is loose coupling. The rule here is that you really need to build loosely coupled systems, because the looser they are coupled, the bigger they scale, and the better fault tolerance they have. What you want to do is to create independent components. Design them as black boxes. So the idea here is that you make a component as a service. The service exposes optimally an API, for example, a RESTful API. The API has known features and is stable. The internal implementation of this service can change. So you can change the language that you use to implement the component services. You can change the functions, how it works, without affecting the services exposed by the API. And here, Netflix has introduced another interesting testing tool called the Latency Monkey. The Latency Monkey is apparently even more difficult than the Chaos Monkey. So Chaos Monkey is disabling services. It's rather easy to notice that something is not there anymore. It doesn't respond. What if the response time from dependent services is getting slower and slower and slower? That's what the Latency Monkey does. So it introduces high latency and slows down the responses between interdependent services. This is a tightly coupled application example. So here you have a receiver component, and it's requesting a function from a transcoder, for example. Now, if the transcoder is slow, the receiver has to wait. So the code is just waiting. It's probably using TCP connections, etc. And your whole application starts queuing and buffering internally, and it may even crash if the dependent party becomes slow or unavailable. So here, the best practice is to use a queue service. Decouple the two components. The first one drops the request in a queue and continues working with the next request. The second party is just reading work from the queue and executing on those. This way, you don't have component A fully depending on the speed of component B. The queue is decoupling them, and it's also acting as a buffer. Here we have a couple of handy services that you should really take a look at. The Amazon SQS, or Simple Queue Service, is an implementation of what we saw in the previous slide. It's a handy way of decoupling your services or your components by introducing queues. So you have workers that are putting stuff in queue, some working queues, and you have other components that are reading work from the queue. There is something called the visibility timeout. So let's say that you have some work in a queue, a worker picks it up, but then it dies. It can happen. What happens to the message that the worker was working on? Well, you can set a visibility timeout. When this time passes, the message goes back into the queue. And then another worker can pick it up and continue working. The SQS is a highly reliable, highly scalable queue service that lets you do this. If you need a more complicated workflow, where you have questions, should I do this one next or should I do that one next? When you have complicated execution logic, a better best practice is to use our simple workflow service. It can reliably coordinate processing steps and manage a distributed state in a complex system. So take a look at simple workflow service if you need to have decision trees in your execution flow. Use SQS for simple queuing and buffering between two components where you know that A needs to talk to B. You know the execution logic. If you have decision trees, take a look at simple workflow service. Then, finally, let's talk about being a data-driven business. Ultimately, what you want to do is you want to save costs, you want to focus, you want to be agile, and you want to iterate your service and application. Startups need to start with an MVP, minimum viable product. Launch your product, put it into production with a very simple set of features, and then listen to your customer feedback. And based on your customer feedback, iterate. Rapidly introduce new services, features, and fixes based on exactly what your customers need. You know this by looking at your data. And then let the data move the levers in your system. Be a data-driven business. How could you do this? Here's an example from our customer, Wooga, which is a gaming company. Now, Wooga have in-app purchases. So they have a freemium model. The game may be free, but then they have in-app purchases, for example, a magic wand to let you do amazing things in the game. They want to compare what is the best way to get people excited about buying this magic wand? A nice way of doing this is A/B testing. Now, what VUCA have done is that they try a couple of different things. They have the old way of introducing the magic wand to the customer, and then they try different things, different options, and see which ones are the most interesting to the customers. How would you implement this in production? For example, like this. Using CloudFormation, Elastic Beanstalk, for example, deploy 2 copies of your system. So here we have the customer traffic from mygame.com coming to the Elastic Load Balancer through Route 53, and then you have 2 autoscaling groups. You have group A with your options A, your first options for your game. Then you have a slightly modified option set for group B. You put both in production, and the load balancer is equally balancing the traffic across these 2 different groups. The most important thing here is then the logs. Collect all the data. These days, with big data, one definition of big data is that data is big data when it's cheaper just to store all of the data than figure out, do I need this data, or what data do I need? So the best practice that we give to the startups these days is just store all of your data. Figure out later what you want to do with that. If you don't store your data, you might be throwing away something that is valuable, where you get insights. So in this example, we have 2 production systems running code version A with different features and B. You collect the logs that contain your customer actions and experiences, and you put them in S3. And make sure to separate them in S3 to test group A and test group B. Now you have your logs. The logs contain the information how people took to your new service in A versus B. Now what? You need to analyze the logs. Here's another service that you really should outsource. Hadoop and related big data analytics tools, massively parallel processing. You basically want to analyze your log files. You might have a lot of log files. That means that a single serialized system like an SQL database no longer has enough performance capacity, storage capacity, and processing capacity to process your logs on time. You need fresh data so that you get fresh insights. You need massively parallel processing. Amazon Elastic MapReduce lets you do this really easily. It's a fully managed and hosted Hadoop framework, including other Hadoop framework open source tools such as Hive, Pig, HBase, R, and Mahout. So Elastic MapReduce lets you really handily and easily create Hadoop clusters, and then you can point your data in S3. This is the source data. You can parallel stream this data into your Hadoop cluster in Elastic MapReduce and then create job flows. The job flows are the map and reduce algorithms that are analyzing your content, your data. There are different ways of doing this. You can use Hive query language, you can use Pig, or you can write the MapReduce jobs in streaming mode using cascading different programming languages. And by the way, if you run Elastic MapReduce, it's a really nice best practice to use spot instances. That's a really good way of saving costs. Hadoop and Elastic MapReduce work really well with spot instances because they can automatically replace any failed or disappearing instances without loss of data. Then you use Elastic MapReduce to analyze your logs and to get the insights. You can keep the results in Hadoop, in HDFS if you want, and with Hive you can create a table. Or you can just export the results from Elastic MapReduce, for example, into RDS, into a SQL database. Those are your results. And then you want to have data scientists who are discovering value in the data. They are creating the MapReduce jobs that are analyzing the content, they are discovering value in your data, and then they visualize it. Using, for example, Tableau or D3, etc. Here we have a couple of nice examples showing how Tableau can be pointed to a database that has the analytics results to visualize your solution. And then, based on the learnings, the insights from the data analytics from your logs, you want to iterate your solution and improve it. So here on the left, in the black, you have your development, testing, integration environment with continuous integration. That is producing new versions of your service. Stored in S3, you have version 1, 1.1, 1.2. To test these, you can, for example, use CloudFormation to just spin up new complete solutions based on your new versions. And then you can execute tests, and you can put them into production using infrastructure as code best practices. Media Molecule is one of our customers who is really happy doing this. So they have increased flexibility, running multiple environments, creating them on demand, paying for them, pay-per-use model, removing them when they don't need them. This allows them to do rapid development and testing. Remember, Amazon Web Services gives you the Lego building blocks. From the building blocks, you build your solution and you start working in the cloud. Go to aws.amazon.com for more information, and remember you can get started with our free tier. Thank you very much. I'm Markku Lepisto, Technology Evangelist for AWS, based in Singapore. And now it's time for the poll. Okay. Okay, excellent. The results are in. And looks like the winning choice is all of the above. Excellent. Thank you very much. Now, please remember, your feedback is super important. So please complete the survey at the end of this webinar. Let us know your feedback, and we will, in an agile manner, iterate our solutions based on your feedback. Thank you very much, and see you next time. Now we can do questions and answers. Now, one question is there a tool to create easily CloudFormation templates rather than doing it by hand? Absolutely. The way that I use it myself is that you can just launch a CloudFormation template called a CloudFormer. So one of the example templates that we have is a tool called CloudFormer. So what it means that you would first build your AWS environment, however you want it, and then you can launch this CloudFormer tool, and it will make a CloudFormation template based on the solution you're running right now in your AWS account. And then you can look at the code, and if necessary, you can start modifying then this JSON template. And remember, it's a really easy way to test it just by launching a new environment based on this CloudFormation template and iteratively improving it then. What is the speed of RDS? And can I pay more to speed up my queue? Well, first of all, RDS, or Amazon Relational Database Service, the speed of the database depends mostly first on your instance size. So remember that you can do vertical scaling. So do performance testing and look at the CloudWatch metrics of your RDS database. And if necessary, increase the database size by spinning up a bigger instance. You can just modify the RDS database and choose a larger instance size. It will reboot with the larger instance size. And if you're running a multi-AZ RDS, it's not going to give you downtime. It will reboot one of the instances and switch the master database to the other one. So that you can vertically scale your RDS instance. But the second thing is, remember Elastic Cache. You can put the Memcached compatible caching solution in front and offload a lot of the requests from your master database. And you can create read replicas, and you can point the read requests away from your master. Then your master just does writes. So these are the different ways how you can scale your RDS performance. The other way then is to really look at DynamoDB and try to design and architect your solution so that you use the RDS SQL database for the complicated queries with joins, etc. And for more simple key value store with really high performance, low millisecond, reliable throughput, look at MySQL. Look at DynamoDB. So have a combination of SQL and NoSQL in your application logic if you can. Then there's a question on A/B testing. Can I have rules saying, for example, 25% of requests go somewhere? Well, one way is using Route 53 and weighted resolution. So with Route 53, you can point different SYS backend systems to your domain. And in Route 53, you can give weights, like 25% of the traffic goes to this system, and 75% of the traffic goes to that system. That's one way of doing that. Another really interesting point to mention here is reduced operating mode. Let's say that something happens to your application code and your production system is not healthy. You still want to serve your customers with some content. So something that I recommend is using content website hosting directly from S3. So have your dynamic website as the production system. But if some really huge calamity happens to that one, you can just basically shift the weight in Route 53 and direct 100% of your traffic to S3. And then do website hosting from an S3 bucket. Now obviously that's not very dynamic, but it can still give a user experience to your customers so that they don't get a 503 service unavailable. While you fix your primary site, and then when that's up and working nicely, in Route 53 you shift the weight again and you send your traffic back to your dynamic site. So look at website hosting directly from S3. There's a question, is the SQL Server multi-AZ? So the Microsoft SQL Server is not yet multi-AZ enabled. Oracle and MySQL are. There's a question, how to decide if one should increase the RDS size or provision more IOPS? That is a good question. It's related to provisioned IOPS. So if you, first of all, you need to look at your CloudWatch metrics. If you identify that, for example, your wait IO is increasing, it means that your processing, whether it's your application or your database, is waiting for IO. So the CPU is limited by the IO. Then you might want to test provisioned IOPS, especially for databases. The best practice is to ensure that the IO performance is good enough. What is good enough? It depends on your load, your requirements, and your solution. But look at the CloudWatch metrics for IO, and then you can test using provisioned IOPS for your EBS volumes. And EBS optimized instance types go hand in hand with the provisioned IOPS. Then you get consistent I/O performance from your EBS volumes. There's a question on 3-tier applications. How are business or data components created? Do we need to create customizations for that? Well, in short, yes. So first you need to design your application architecture. You want to specify, do you have a presentation tier, maybe the web servers? Do you have an application tier, which is maybe separate from the web server tier? And then your data tier, which could consist of RDS SQL databases, or DynamoDB, NoSQL, or both, etc. But a lot of the companies we see these days do a so-called 2-tier. So they have maybe their web servers and applications in the front-end instances. Naturally, they have their own customized AMI stem, whether they are orchestrated or not, using something like Chef, Puppet, or Ansible, or pre-baked AMIs. You have your application tier in front, which is auto-scaling and load-balanced, connecting then to the data tier, which could be a combination of SQL and NoSQL databases. But you need to design this, and we have solution architects that are more than happy to work with you on those. Are there any special considerations to keep in mind when developing Java, Node.js, PHP apps to run on Beanstalk? No. So basically, you can just code as normal using Beanstalk, and then Beanstalk will let you very handily create the execution environments, scale them for you, self-heal them for you with auto-scaling and load balancing, manage your databases, manage your CNAMEs, etc., where you point your traffic. So basically, you can just use your favorite integrated development environments like Eclipse, you can use Git, etc., and you can just push your applications into Beanstalk to be executed. Is there a chance that the Elastic Load Balancer could fail? Well, it's inherently built to be a highly available, reliable solution. So Elastic Load Balancing does not consist of single points of failure, no. When is the best time to start using EMR or Elastic MapReduce? Very good question. I would actually like to say now is the best time, because you want to be a data-driven business. You want to iterate your application and features based on customer feedback. You don't know what you should do unless you look at your data. Your data contains the insights. You want to get to the insights. But you don't want to have a data analytics solution that is performance bound, that will reach its maximum when you scale up to a certain level of usage. So Elastic MapReduce lets you really easily do massively parallel processing of your log files and have actionable insights from your data. So I would start playing with EMR immediately, which I do. What kind of alerting and monitoring means are available? Well, we've talked a lot about CloudWatch today. That's collecting the metrics, both standard metrics and customizable metrics from your system. Then we have SNS, Simple Notification Service. So you can subscribe to different topics. We can notify. You can configure notifications where something important happens in your system. Some people use SQS, Simple Queue Service, also to pass messages of events to other systems. For example, EMR, Elastic MapReduce, includes Ganglia integrated, so you can use Ganglia to monitor your Hadoop clusters, both the cluster and the node. We have simple email service, etc. So you have a lot of ways, and you want to monitor. So that's another thing. Besides collecting the logs, make sure that your monitoring and metrics are in order. You need to know what's happening to your system. Okay, one last question after this. If the site is down, Let's take this one. The question is Beanstalk more of a prototyping environment from which you would then say build a CloudFormation template, or is it intended for ongoing production? Very good question. It's definitely intended for ongoing production. The difference is really personal preference. So Elastic Beanstalk, actually I recommend that for people who really want to just focus on application development, because then Beanstalk will handle all the undifferentiated heavy lifting and muck on your behalf. You just focus on the application development. You have continuous integration and deployment chains that deploy and push new application versions into production, and Beanstalk handles everything else. Scalability, replacement of failed instances, database management, etc. What is then CloudFormation? Well, CloudFormation is another option. The main difference is that with CloudFormation, you describe your entire solution as JSON code. So it's infrastructure as code. And then you can store this code in version control. With CloudFormation, you have more choice and control for your infrastructure components. If you want to do that, you can do that very easily with CloudFormation. But with Beanstalk, you make the decision that you don't care. You focus on your application development, and Beanstalk does everything else. So if you're interested in these application management solutions, I recommend you to take a look at both and see which one you prefer. In addition to that, we have OpsWorks, and you have always the option of fully managing your application and configuration by yourself using EC2, etc.
You just said that we got a big stack of questions. We're kind of responding, but some of them we've been waiting for a while. There's like 100+ questions in there, so just to show that I'll continue to answer.
Okay, so now we are at the end of this webinar. Thank you for your great questions. We still have a lot of questions, good questions that we didn't have time to answer here online. We will come back to those, so we will definitely try to respond as many as we can. Now I would like to really thank everybody for the good questions and for joining this session. I really hope that you enjoyed it. And until the next time then, it's been a pleasure. I'm Markku Lepisto, Technology Evangelist for AWS. Thank you and see you next time. Goodbye.